Namaste. Today we will discuss a topic called hypersonic expansion wave relation. Right? You may have some experience already on compressible flow, and you have already studied the compressible flow, and you have derived the Prandtl-Meyer expansion. Right? So we will be expanding that Prandtl-Meyer expansion, right, for the shock wave relation, right? I mean, for the hypersonic expansion. Right? So I acknowledge the John D. Anderson's hypersonic and high temperature gas dynamics, right? Now, say, let us consider a centered Prandtl-Meyer expansion, right? So here, Prandtl-Meyer expansion around a corner of deflection theta. So you have a theta here, right? And the expansion fan consisting of the infinite number of Mach waves originating at the corner, right, and spreads down the downstream, right? So spreads down the downstream, and we consider M1 is a Mach number, and P1 is a pressure in the upstream, and M2 is a Mach number, and P2 is a pressure in the downstream, right? So we know here the corner deflection angle is theta. Now let us go back and derive the Prandtl-Meyer expansion for this case, and then consider the hypersonic flow, right? So we already know that for a Prandtl-Meyer expansion, right, we can say that theta, right, we can say that theta is equal to nu of m2 minus nu of m1. Basically, we have this relation, right? Now, let us say we already have an information about the Prandtl-Meyer expansion. So we can write for one particular Mach number of gamma of m, say gamma of m, we can write root of gamma plus 1 by gamma minus 1 into tan inverse of root of gamma minus 1 by gamma plus 1 into m square minus 1, right? So this relation we have already derived in the compressible flow, minus tan inverse of root of m square minus 1. I recommend you to derive with me, so it will be very easy, right? So we can write gamma of m is equal to root of gamma, I mean nu of m is equal to gamma, I mean root of gamma plus 1 by gamma minus 1 into tan inverse of root of gamma minus 1 by gamma plus 1 into m square minus 1 minus tan inverse of root of m square minus 1. Now, we have in hypersonic flow, we have an assumption, right? We consider for large Mach numbers, right? Say for large Mach numbers, right? We can write root of m square minus 1 will be almost become m. Right? So we can rewrite this equation, say this equation gamma nu of m is equal to root of gamma plus 1 by gamma minus 1 into tan inverse of root of gamma minus 1 by gamma plus 1 into that root m square will become m minus, right, minus tan inverse of m, right? Because we consider the m square minus 1, right, become m. Now we have m1 and m2, right? Again, we have tan inverse of m, so we should use the trigonometric identity, right? So let us consider the trigonometric identity. Here we can consider the trigonometric identity. So trigonometric identity we can consider, and the tan inverse of, say, tan inverse of x can be written as pi by 2 minus tan inverse of 1 by x, right? Now you know the series expansion, right? Series expansion we have studied. By considering the series expansion, right? By considering the series expansion, the tan inverse of 1 by x can be written as 1 by x minus 1 by 3x square, not x square, x cube, plus 1 by 5 x power 5 minus 1 by 7 x power 7, and it will be keep on going, right? So let us combine these two equations, say this equation 1 and this equation 2. Now we can write the tan inverse of x, right? So we can write the tan inverse of x is equal to the pi by 2 minus, see here, tan inverse of 1 by x, that can be written as 1 by x plus 1 by 3 x cube plus minus this become minus, right? This become minus 1 by 5 x power 5 plus 1 by 7 x power 7 plus. So we know tan inverse of x and tan inverse of 1 by x, right? So tan inverse of x we know. Let us go through that, right? So so we can write this as, right, mu of m can be now written as root of gamma plus 1 by gamma minus 1, right, into tan inverse of root of gamma minus 1 by gamma plus 1 into m. So we can use tan inverse of x. Then here we can write that pi by 2 minus root of gamma plus 1 by gamma minus 1, right? into 1 by m, and we can go further, right? We will come back to that point, minus tan inverse of m, right? Minus tan inverse of m. So tan inverse of m can be written as pi by 2 minus 1 by m plus, we can go further. So this equation now in terms of m, right? So here we know that there are a lot of higher order terms, right? 1 by m cube, 1 by 3 m cube, here also 1 by 3 m cube and all. So here what we do is like, say if as we consider the Mach number is large, the m infinity is large enough. So here we neglect 1 by 3 m cube, 1 by 5 m power 5 and so on. So we ignore, right? We ignore the higher order terms. We ignore the higher order terms, and then we can rewrite this equation as mu of m is equal to root of gamma plus 1 by gamma minus 1 into pi by 2, right? Minus, if you multiply gamma plus 1, so it will become gamma plus multiplied by 1 by m plus, okay, then we go to the next point, pi by 2, right? So this is the equation we have now, right? Mu of m, right? So let us say this equation number 3. Now we already know that theta is equal to mu m2 minus mu m1, right? So we can write this equation. So here we can write mu of m is equal to root of gamma plus 1 by gamma minus 1 into pi by 2 minus gamma plus 1 by gamma minus 1 into 1 by m2 minus pi by 2 plus 1 by m2, right? Minus root of gamma plus 1 by gamma minus 1 into pi by 2. The minus and minus become plus, hence it becomes gamma plus 1 by gamma minus 1 into 1 by m1, and the minus and minus become plus, pi by 2 minus 1 by m1. So what I have done is I have just substituted this m1 and m2. So we can cancel this one, and the again pi by 2, right? Now we can write the equation again. So we can write the equation in terms of theta. Theta is equal to 1 by m2 minus gamma plus 1 by gamma minus 1 into 1 by m2 minus 1 by m2, not m2, this is m1, 1 by m1, right? This become 1 by m1 plus gamma plus 1 by gamma minus 1 into 1 by m1, right? So this is the equation, right? So from this equation, we can rearrange this equation. So let us rearrange this equation. So let us consider any one, and if you rearrange, so this will become, say, if you consider this and rearrange, right? So this will become like 2 by gamma, right? So maybe we can write something like this, into gamma minus 1, right? Then gamma 1 minus gamma minus 1, right? I write this as minus, right? So, okay, sorry, if we consider here, it should be gamma minus 1. Gamma minus 1 minus gamma plus 1, right? So this becomes like, this gamma and gamma goes, and finally you will get uh, 2, right? This also becomes minus of minus. So this becomes 2 by gamma, so 2 by gamma minus 1 into m2. So finally we can write this equation, theta is equal to 2 by gamma minus 1 into 1 by m1 minus, because here you see, in this case it will become minus 2, right? So 1 by m2. So this is the final equation in terms of theta. So this is the hypersonic relation for Prandtl-Meyer expansion wave. So we can say that this is the, hypersonic hypersonic right? So this is the hypersonic relation. Hypersonic relation for Prandtl expansion, right? So this is the hypersonic relation for the Prandtl-Meyer expansion waves. Okay, but we already know that this hypersonic relation where M1 and M2 are the upstream and the downstream Mach numbers, and the theta is the flow deflection angle, deflection angle, right? So again, calculate the coefficient of pressure. Right? You remember coefficient of pressure again. So let us use this basic isentropic relation to calculate the coefficient of pressure. Right? And the theta will be always a positive quantity because it cannot be negative. That also you need to remember. Right? So let us start with the isentropic relation. Right? So the flow through the expansion wave is isentropic. Right? So flow through expansion wave is isentropic, and we can write now that P2 by P1, that is equal to 1 plus gamma minus 1 by 2 into M1 square by 1 plus gamma minus 1 by 2 into M2 square. The whole power gamma by gamma minus 1. Right? So by having a very large Mach number approximation, right? In hypersonic, we always say that very large Mach number, considering very large Mach number, here that one have no meaning, and then we can write this equation P2 by P1, that is equal to M1 square by M2 square. Only this is M1 and M2 square. M1 square and M2 square, and this becomes gamma by gamma minus 1. So we can further write M1 by M2, the whole power 2 gamma by gamma minus 1. Right? Because we know that this one will be ignored because of the large Mach number, and then this gets cancelled, and this becomes this equation, and this becomes this equation. Right? Now, we studied something called M1 by M2 somewhere. So in the Prandtl-Meyer expansion, we have M1 and M2, right? So now it is possible to reduce this equation. Right? So we can reduce this equation M1 by M2. We want M1 by M2. Right? How can we calculate M1 by M2? Say we have the point that theta is equal to theta is equal to 2 by gamma minus 1 into 1 by M2, right? M1. 1 by M1 minus 1 by M1 minus 1 by M2. Right? So we need to calculate m1 by m2 here. Right? Say theta is equal to 2 by gamma minus 1 m1 m2. Here it can be m2 minus m1. Right? So we can write this somehow, say gamma minus 1 into m1 m2 into theta is equal to 2 into m2 minus m1. And finally, you can rearrange this, right? This gamma minus 1 by 2 will come here, and by doing an approximation m1 by m2, so this become 1, and here this m2 will go away. Then we will have 1 minus gamma minus 1 by 2 into m1 theta. Right? And you know very well that this m1 theta is a hypersonic similarity parameter. Right? M1 theta is equal to hypersonic similarity parameter. Now m1 by m2, so we can write the next equation. Right? So we know the P2 by P1, right? What is P2 by P1? Say P2 by P1, that is equal to, that is P2 by P1, M1 by M2, right? M1 by M2 for 2 gamma by gamma minus 1. So here P2 by P1 can be written as M1 minus M1 by M2, that is 1 minus gamma minus 1 by 2 into M1 theta become K, the whole power 2 gamma by gamma minus 1. Right? So we arrived at the P2 by P1. Okay. So again, ultimately we want to calculate the coefficient of pressure, right? So P2 by P1 is equal to 1 minus gamma minus 1 by 2 into K, the whole power 2 gamma by gamma minus 1. So we can write Cp, that is equal to 2 by gamma m1 square into P2 by P1 minus 1, that we know already. So let us write this equation by P1, gamma m1 square into 1 minus gamma minus 1 by 2 A, the whole power 2 gamma by gamma minus 1 minus 1. Right? So now this equation, see here, this equation you have only one m1 is a function of gamma m1 and all. So let us do one more thing. Let us divide this Cp by theta square. So multiply and divide by theta square. Multiply and divide by theta square. We can write Cp will become 2 theta square by gamma, and here you have m1 square, so if you multiply it by theta square, it will become k square. right? Theta square by k square, and then you will have the remaining term, that is 1 minus gamma minus 1 by 2 k the whole power 2 gamma by gamma minus 1. Okay, now you see this Cp by theta square, if I consider, I can write it in terms of, in the function of gamma and k, right? So this is the final expression, right? 2 theta square by gamma k square into 1 minus gamma minus 1 by 2 into k the whole power 2 gamma by gamma minus 1 minus 1, right? So it is almost like for the expansion wave also, it is almost analogous to the shock wave Cp, right? That is also the function of gamma and k, right? So here Cp by theta square is equal to function of gamma and k, right? So ultimately what we have done today is, like, first we have derived the theta, right, for the expansion wave, basically mu of m2 minus mu of m1, and then we know p2 by p1, right? P2 by P1 is equal to 1 minus gamma minus 1 by 2 into k the whole power 2 gamma by gamma minus 1. Then we have substituted this in the basic equation of Cp, and we have the final expression for Cp. And finally, we found that Cp by theta square is in terms of functions of the hypersonic similarity parameter k and gamma, right? So thank you very much. I stop at this point today, right?